Here we are in question 5. You can move the points in the plots. Click on the point in the dot plot representing the largest height. Note that when a point is selected, it will be shaded. Move that point, describe what happens. Okay. So if we come over here, and you'll see that I already moved it here. When I clicked on it from either spot, it turns gray with the border, so I can move it around, and notice when I move it, this one moves with it. When I grab it and it becomes gray with a black border, so does this one. So that's answer A. Come back here to B. It says drag the maximum point to the right, creating an outlier. At what value does it become an outlier? There's a couple ways you can do this, but I'm going to go ahead and ask you to do a visual answer here. So if we come here and we drag this point out here to a little past 84, I'm going to consider this an outlier, and here's why. Because it's separated by the main group of data. And so this data here is clustered, it's tightly concentrated, there's several data points, but notice as we get to the right they get more spread out, and there's gaps between them, especially gaps to the left. So the greatest outlier here would be 84, because it is so far from the concentration of these data points. For part C, I'm going to show you the math involved in that. It's a little more complicated. So it says, part C says, explain how you can check mathematically determine if the value is really an outlier. It says the definition for an outlier in a box plot is any value that is greater than the upper quartile, which is this part right here, so 68.1, plus 1.5 times the interquartile range. So they did plus 1.5 times the quantity, 68.1, minus this 59.9, and that gave us 68.1 plus this quantity here became 12 3/10, and it equaled 80.4. So any height greater than 80.4 inches will be considered an official mathematical outlier. So please remember to answer all 3 parts. If you're confused about any of these, you can rewatch the video to get some clarification.